Hello and welcome to another exciting experiment session at Heathlands. We're celebrating British Science Week. My name is Dr. Deathclaw and this is here Brian, my glamorous assistant. Today we're going to be talking about magnetism, ladies and gentlemen. Hey Brian, what were you doing roughly 13.7 billion years ago? Well, I'll tell you.
I wasn't here.
Well, I'll tell you, no, you were. We were all there. Every single thing in the universe, ladies and gentlemen, all of time, all of space, all of energy, all of the matter that was yet to come was compressed into a tiny ball that we know as the singularity, which then exploded in the Big Bang. And shortly thereafter, Brian, I think it was about 2:30, it cooled down enough for 4 of the fundamental forces of nature to form and separate. Before that, it was one unified force. After that, it became the strong the strong nuclear force, the weak nuclear force, gravity, our old friend, and electromagnetism. Okay, so electricity, magnetism, they're linked, the two sides of the proverbial coin, ladies and gentlemen. But what is magnetism? We've all sort of used it, we've all seen it, played about with magnets, which is what we're going to do today, Brian, you lucky boy. But what magnetism actually is, it's things aligning in a line. In every atom there is electrons, and some things are more magnetic than others. For instance, Brian, even your head, would you believe it, is magnetic, but only little, because all your atoms, the ions in them, aren't aligned, yeah? But other things have more alignment, i.e. iron. Yeah, so it can make magnets out of iron and other various metals. So that is what magnetism is, and all things have a magnetic field, including our very own planet Earth, what we live and breathe on. Yeah, and when you get stuff like the Northern Lights, that is high energy particles buffering our own magnetic field, which is caused by the iron core of the Earth spinning and creates a magnetic field. And what we see as the Northern Lights is that field being bounced, being pushed, and the high energetic particles interact with things in the atmosphere like oxygen for different colours. Anyhow, enough of us chunting on. You didn't tune in to hear us talk about magnetism. You want to see it, don't you? So, ladies and gentlemen, prepare to be mildly astounded as we delve deeply into the force of magnetism, starting with the Earth's magnetic field. Ooh. So here we are, ladies and gentlemen, on this plinth of science is a compass. Now a compass follows the force lines of the Earth's magnetic field, and that little red pointer is pointing to magnetic north, yeah? Okay, so it's pretty stable, But as my glamorous friend and assistant, Mr. Brian Jefferson, slowly brings the magnet towards and under, not that slow, you will see the pointer change. That's because the field strength of the magnet he is holding is stronger over a short distance. The Earth is far more powerful on a bigger scale, but on the shorter scale, it plays havoc. It plays havoc, doesn't it, Brian?
Yeah.
Yeah? So you can sort of move it around, and make it go towards that. But once you take it away, Brian, if you take that out to the road, thank you very much, sir. Oh, I've gone off.
Just touch it with your finger.
Oh.
It's just saying battery, not the record, the screen.
All right. Oh, sorry. Okay. So, as you can see, as he's moved it away, the Earth's magnetic field is reasserted itself over the larger and shorter distance. So that is the Earth's magnetic field, ladies and gentlemen. And that's why we use it in navigation, because it doesn't matter where you are on the Earth. If you have a compass, you can find due north, and from due north and the position of the sun, you can mostly, not that accurately, but you can, our ancestors did for tens of thousands of years, to not get lost. So that is the Earth's magnetic field. Next, we were moving on to making a magnet, would you believe? So, we've had a bit of luck at the old Earth's magnetic field. Let's bring it down a peg or so and see if we can make a magnet. Now, Brian, have you got a couple of nails on your person? You're the sort of person.
I do.
He does, ladies and gentlemen. So let's have a look at them. So they're just two. It's like I'm doing a magic trick. Well, I suppose it is. Two ordinary, standard nails. So, Brian, I'm going to put one on there.
Yeah.
Yeah, like so. And yeah, I'm going to get you the other one, and I want you to touch it on there and see if it's magnetic. If it's magnetic, it will stick to it. Go on then. It's not going to give you electric shock. No, nothing's happening there,
No.
is it?
No.
Is it? No, that's because even though this is metal, Brian.
Yeah.
See its atoms, if you look closely. Yeah?
Yeah.
I don't know if you can quite make it out. But those atoms are not aligned. They're all a bit all over the place. If only there was a way of aligning those atoms.
Yeah.
Ah, no, I've got an idea. I'm going to get another magnet. And Brian, what I'd like you to do, right? Now it's quite thin, so I want you to just stroke it.
Yeah.
Like that. If I hold this, and watch your fingers, no, you hold them. You hold that, right. Yeah, and then like that. So keep going. And what we're doing is we are forcing, and force being the correct word, all the atoms go from the bottom bit to align. We're moving them one way up. Now, we haven't rehearsed this.
No.
So we'll do it a bit more. Okay, that should do it. Now, Brian, let's have another go. Just slowly bring it up to there and see if that moves. Please move. Well, ladies and gentlemen, an abject failure. Hang on, that must be, hang on. I'm just going to give it a quick thing. Oh, we've got a slight movement. So maybe if I just do this quickly, Brian, because I think we need to be more rapid.
Yeah.
Yeah,
Okay.
and aligning all of those lovely little atoms. It's not going to be as strong as this magnet.
Right, okay.
But maybe we can whip, if we want to see it, maybe a more accurate method would be using our old friend the compass. But we're going to just see. Yeah, it's got a little bit. So, I am now going to hold this up. Oh, Brian is. Like that. I don't know if you can see there. I'm going to just do it like that, yeah. And I'm going to bring this in. Hello, have we got any movement? I think this is what you call a failed experiment, Brian.
Yeah.
It is slightly magnetic. Yeah, I can feel it. But I think it would probably take a longer time. But wait, hang on. So what we'll do is just cut. We can do this in the edit, right? So I've got one nail that I've partially magnetised, ladies and gentlemen, and one that isn't. But to show you, if we had more time, how to do this, how magnetic force lines travel through things, I will get our friend, stuck to my chair, Mr. Magnet, as a big strong one. Now, Brian, odd that in your little pinkies. Now, that hasn't got any, but this will have the magnetic field from this here magnet going through it, and with a bit of luck, if you let go, as you can see, ladies and gentlemen, look at that.
Yeah.
And that, ladies and gentlemen, is science.
Yeah.
Right, we'll now move on to our next experiment, which I'm going to call Fun and Games. There you go. Well, this has all gone perfectly. So, we've started a little bit talking about magnetism and attraction. Yeah, attraction. But now I'm going to talk about repulsion, aren't we, Brian?
Yeah.
So, as I said, things are aligned. That means they want to go one way only. But when those atoms are going one way only and the other ones are going the same way, even though I've turned it my arm round, they will try to force each other apart. We will now, ladies and gentlemen, show you. So, for instance, I don't know if this is it. I can see it. Yes, there we go. So if Brian passes a magnet, just one of them, and just put it on, whichever one it is. It doesn't really matter. So pop that on there. Now, Brian, can you give me a blue? Okay. Now, I'm just going to grab this just to show up first because we're going to be taking off. Okay. So these two magnets now, ladies and gentlemen, are going to be attracting one another. So they stick together like so. However, if I put the same one on and give me one with red facing down. Right, and do you want to put that on the top there, Brian? Let's see what happens. Oh, hello.
Oh.
No, instead, ladies and gentlemen, of them being attracted to one another, they are repulsed. Now, I could actually make this fly off, but I won't. But that's the sort of power we're talking about. The closer they are, the more force of repulsion there is, and the more they want to get away from each other. But well, let's have a bit of fun. Can I have a blue, please, Brian? We're saying blue and red because they represent the different poles of the magnet. So if I put that on, hello, ladies and gentlemen. Give us another. I want a red this time. Good lad, do you want to pop that on the top? There you go. So hang on. Red on the bottom, lads. So okay.
Sorry.
So all of those have opposing between the two. Those two are attracting. Yeah. And those two are attracting. But so that sort of cancels out, and that's why they're all repulsing one another. Keaton, you give us a blue. Blue on the bottom, off you go. There we go, ladies and gentlemen. As you can see. And let's put the last one on so we want red facing down, Brian.
Like that.
Like that. Pop it on. There we go, you see. So now we have all 6 magnets, yeah? And as you can see, gravity takes hold a bit there, yeah? That's just the literal weight of them, but still they're repulsing or overcoming the local force of gravity, And to get them off, if I just rotate, hello, that one pulls to that one pulls to that, and off, hello, I've gone Raj. So that is briefly repulsion. We will now show you another little repulsive trick. Ladies and gentlemen, the heat is on. Using the power of magnetic repulsion, me and Brian here are going to have a race to the death. Not the death, the finish line, which I'm going to say is here. But how we're going to do this? We're going to do it by not physically touching these 2 little cars. Why is that, Brian? I'll tell you why. Because they are basically, ladies and gentlemen, you'll probably see it here, I'm just going to bring it up, a bar magnet with wheels. So what we're going to do, as you can see on there, we've got a red and a blue, a north and a south. And we also have, that we are going to hold, a red and a blue, a north and a south. Now, as we've discussed, if we hold the north to the north, they will repulse. Yeah, so by using the power of repulsion and nothing but and sleight of hand, we're going to have a race.
Yeah.
Are you ready for it?
Yeah.
Okay, game on. I'll do the countdown so you don't cheat. Right, remember, I want a clean fight.
Right, okay.
Right, Brian. 3, 2, 1, let's get it on. And as you can see, those magnets are repulsing one another. We've got to get him for the crash here, Brian. No! Oh, I'm winning him. Storming it. Oh, see now. Right, see. This doesn't happen in Formula 1. But that's what happened here, you see, because those 2 cars there are now attracting one another, the dirty boys.
Yeah.
Right, so we'll start from here. I need cheating.
Don't cheat.
Right, the final bit. Ready, go on. 3, 2, 1, gun. Oh, it's going to be a dead heat, this, I tell you. Oh, Brian, man. Brian, obviously, using cheating.
No!
Obviously,
No,
he couldn't have won
cheat.
further. But again, using these 2 magnets, hang on, I'll just put my thing aside to see, these 2 magnets which either repulse or, oh, hello, sailor, or attract. I think here we go, look at that. They're not as strong as some magnets. Okay, so that was a bit of repulsion. But you guys are talking about magnets all the time. Where's this magnetic field? In the next part, I'm going to show you. Ooh. Okay, so we have, as our apparatus say, I've got a little petri dish, ladies and gentlemen, that's full of iron filings, tiny particles of iron, yeah, and they will show the magnetic field quite well, I think, once my friend and lab assistant Brian, what's that in your hand? Is it a magnet?
It is.
Whap it under the filings, pal. So I'm going to hold this steady, and if you move it around, there, you can see, ladies and gentlemen, go around in big circles, Bryce, so there we go, yeah, and as you can see, a bit slower, and as you can see, those files are aligning, yeah, aligning with the magnetic field that's surrounding that magnet, yeah. That's pretty cool, isn't it?
Yeah.
You know what I mean? I mean, you have things like MRIs, magnetic resonance imaging, that's when we're putting a really strong magnetic field and it can pick up things within us, you know, for medical purposes. Okay, we're now going to move on to our final experiment of the day, which is taking it up a level in terms of danger and also unrehearsed action, where we're going to be using a thing called ferrofluid, which is a liquid-based stuff. So let's give it that again then, eh?
Yeah.
Okay, here we go. Right, ladies and gentlemen, final experiment of the day. We're bringing up the big guns. Do you know what this tackle is?
No.
Ferrofluid.
Right.
Okay, so what it is nanoparticles of magnetite suspended in a fluid, yeah? So this might show the magnetic field more than a 3D manner. Now it's not dead, it's not going to blow the place up. But it's if you get it on your hands, it's not a question, it's going to, steady. It just gets into pause because we're talking about using nano materials, ladies and gentlemen. So first of all, I'm going to carefully unscrew my cap. As you can see, we fully safed it up. Do you know what I mean? Goggles on the lot. And using this here pipette, I'm going to take a few bits out. Here we go. That was quite a bit there, more than I thought.
Ooh.
And as you can see, it's a dark liquid. Now I'm just going to put a little pool of that. Now we've never done this experiment before. We haven't had time to rehearse or anything like that. Now what I'm going to do is just put this on. Yeah, I'm going to put the lid on first of all, because I don't want it ganning everywhere, do I?
No.
That would be what's known in the scientific
A
community
disaster.
as a power down, Brian.
Yeah.
So I'm going to place this out of arm's reach over there. I'm just going to use a bit of glue roll over here, just to get that on there, because I don't want it gone everywhere. Now then, ladies and gentlemen, let's just have a look. I'm just going to check this so I can see what I'm doing. Okay, so there we have our nanofluid. Now, Brian, slowly and from below, from below, I can't stress that enough.
Right.
Put the lid on.
Oh yeah, I've put that on. Sorry about that. Just said safety tips there, Mr. Mark Watson. Thank you. But even so, let's put it under there and see what happens. Go on then, off you go. No, I mean I'll do it up onto there. Hang on. There we go. So move it all around the liquid, right? So bit slow, lad. So hang on. Can you just give it a second, because we've got to. So if you just move it, sort of like that. I was wanting the lady's job to see that. Can you see those spikes, Brian?
Yeah.
Yeah?
Yeah.
And I thought, that is amazing, isn't it?
Yeah.
That is amazing. Yeah. Whoop, whoop, whoop.
Yeah.
Now then, is the camera picking that up? I think it is. That is kind of a fantastic thing. Yeah? If we had a different strength, electromagnet, you can spin round and stuff like this. But yeah, can you rotate the magnet in your hand there? And you can see it rotating. Yeah? On there.
How's that?
Should we try with a stronger magnet?
Yeah.
Let's have a go. Move that out the way then. Now I'm going to do this one, Brian, in
yeah.
case it all goes on it wrong. I'm expendable, Do you know what I mean? So here we go. I'm going to use the larger magnets, the more powerful. Here, now look at that. Yeah.
Oh,
now I don't know if the camera can pick it up. You can just see like a round blob, but oh my word, it's moving. Can you see it moving, Brian?
Where?
Right, I'm just holding that still. Right, have a look beside the. Oh no, you can't stand up, can you? Hang on, I'll bring it to you. Can you see it moving?
Oh, yeah.
Maybe if we could get an extra camera in, because that's looking absolutely fantastic.
Yeah, it is.
So you can see that movement down. As I turn it, it moves with a glorious. How fine is that?
That's really good.
It is pretty neat, that, actually.
Yeah.
Yeah. Can you pick that up, Mark? How is it? That's looking absolutely fantabulous. And what I'm going to do, I've decided I'm going to go for bringing two different strength. And I'm going to say, oh no, one's linking towards the other. Hello, look at this. It's all happening. Whoa! So that is jumping between two different strengths, yeah? And I think that is beautiful. Now, the thing is, you see, that's what if we were able to see magnetic fields in real life, that's what we'd see all around us. Yeah?
Yeah.
It's just special effects, isn't it, in real life? So, that, I think, takes us to the end of this amazing journey.
That is fantastic.
Into magnetism.
Yeah.
So, there we go then. That's magnets sorted. A big, massive thank you to you, Brian. It was actually very well done there. Good man.
Thank you.
So pretty science week all the way, innit?
Yeah.
Heathlands at home. Pushing boundaries as ever. Next week, nuclear fusion.
Exactly.
Goodbye.
Goodbye.